Hi, my name is Andrew Kurd, and this is my Unit 2 presentation mapping demonstration. So the data set we were given is all the offspring totaling for 5,742 between a homozygous recessive and either a hemizygous or homozygous dominant partner. When organizing these data set, we get four distinct events. The first is no recombination events, which has the offspring either being plus 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 or ABC, and this is the most common and yields the most offspring of this phenotype. The next one is C crossing over, where the genotype is either plus plus C or AB plus. B crossing over, where it's either A plus C or plus B plus, and A crossing over, which is either A plus plus or plus BC. Um, After organizing the data set, we can look at the data set to see which are the recombinant and double recombinant cases. The crossing over event that yields the fewest number of offspring is the double crossing over event. So if we total up all the offspring from each of the cases before, A crossing over, B crossing over, and C crossing over, we see that A crossing over gives us the fewest total number of cases at 240. And so that means that A crossing over is the double recombination event, and B and C crossing over is a single recombination event. After finding out which is a double recombination event, we can then find out the correct order of the genes. In order to do this, we can place down the order of the genes and see what it would look like if there was a double recombination event in that particular order. And whichever double crossing over event gives us the correct phenotype from that we saw last time, we know that gives us the correct order of the genes. So by looking at all these, option 2 produces the double recombinant phenotype that we saw last time, which was A plus plus or plus BC. And we can see that with this cartoon. And due to this, we know that the order of the genes goes BAC. So now that we know the order of the genes, we can find the map distance. In order to do this, we need the total cases of B added to total cases of B crossing over added to all the total double recombination cases. We divide that total by the total number of offspring and we multiply by 100. So in this case, from finding the map distance from B to A, we add all the cases of B crossing over with the double recombination event and divide that by 5,742, times it by 100, and that gives us 18.5 map units. Now we can find the distance from C to A. In order to find the distance from C to A, we take the total cases of C crossing over, add it to the total recombination cases, and divide by the total offspring, just like we did for the last one. Doing the math, we'd get 1,010 plus 970 plus 100 plus 140 divided by 5,742 times 100, and that will give us 38.7 map units. We can now map the chromosome, as you can see by the figure here on the left. B to A are closer to each other with 18.5, and A to C farther away with 38.7 map units. Now that we've found the map units, we can calculate the coefficient of coincidence. So the coefficient of coincidence is defined as the actual number of double crossover events divided by the expected number of double crossover events. So the expected number of crossing over events is the probability of B crossing over multiplied by the probability of C crossing over. And the actual double crossover events is the total cases of crossing over that we got in the offspring divided by the total cases. So when looking at the expected double crossover event, we take the probability that B and C crossover, which we got from calculating the map units. So it's 0.185 times 0.387, and that gives us 0.0714. And we multiply, and the actual double crossover event is just taken from the raw data, which is 100 plus 140, because those are the actual number of cases that had a double crossover event. We divide that by 5,742, and we get 0.042. So if we divide the actual double crossover events by the expect double crossover events, we will calculate the coefficient of coincidence. For this case is 0.588. With a coefficient of coincidence, we can then calculate the interference. Interference is I equals 1 minus C. C is the coefficient of coincidence. So here would be I equals 1 minus 0.588, and we get I equals 0.412. Since I is positive, it means that there is chromosomal interference affecting the chance of a double crossover event. And yeah, that's my presentation. Thank you.